This is part 8 of square roots and radicals, and we're going to expand our work with radicals by discussing cube roots, fourth roots, etc. Let's begin with looking at perfect cubes, perfect fourths, etc. So what we have are some perfect cubes here in green on the left. 2 cubed, remember, means 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27, etc. So for instance, you can see some of the perfect cubes would be 8, 27, 64, 125, 216, 343. I've memorized up to that, but you don't have to memorize that far. You could always figure it out by multiplying the 3 numbers out together again, right? 5 cubed, you would just do 5 times 5 times 5, and that's how you would get 125. If we look at some of the common perfect fourths, that would be 2 to the 4th power would be 16. 3 to the 4th power is 81. Remember, you get that by doing 3 times 3 times 3 times 3, which is really just 9 times 9, or 81. And we have 4 to the 4th, 5 to the 4th, etc. Now, if we're looking at the 5th power, I only know the first couple of those. 2 to the 5th is 32. 3 to the 5th is 243. And once we're after the 5th power, I really only know them for 2. 2 to the 6th, I figure out, is 64. You just keep multiplying by 2, and you can get up to the 2 to the 10th pretty easily. And what I do remember is that 2 to the 10th is approximately 1,000. It's a little bit bigger than 1,000. It's 1,024. All right, so we have to have an understanding of what the perfect cubes, the perfect fourths, the perfect fifths, etc., at least some of them, or be able to figure them out. And now when we use a radical sign a little bit differently, for instance, when we write this symbol, we think of this as the square root of 4. Right? Okay. Well, square root of 4 can be written as a little 2 in this little spot here. Okay, but it's usually left off because we recognize this is the common radical sign. This square root without the 2. You can write it either way, but basically it still means 2, right? Same thing. If I want to do the square root of 25, you could write it with a little 2, and that tells you this. What 2 numbers multiplied by themselves is 25, and that would be 5. Okay, so this is called the index, this little number in here. So when you have, this is the radical sign. It's called the radical sign. And the number in here, the little n, is called the index. Right, so what would this mean? If you put a little 3 in there, and I put 64, what it means is what number cubed equals 64? All right, so you could either memorize that, or you could try to figure it out by saying, well, is it 2 times 2 times 2? No. Is it 3 times 3 times 3? No. Is it 4 times 4 times 4? And yes, it is. So the cube root of 64 is 4. What if I did the cube root of 27? I would say what number to the 3rd power is 27? And that would be 3. What if I wanted to do the 4th root of 81? This would mean what number to the 4th power is 81? And that would be 3. Either you memorize it, or you could break down 81 to figure that out. So if you didn't know what it was, you could say, well, 81, let's see, that's 9 times 9, just doing a little factor tree. And then you say, oh, 81 really is 3 to the 4th power. So the 4th root of 81 is going to be 3. All right, try these 4 problems. Put it on pause, then come back. All right, let's do the first one. Cube root of 125. What cubed is 125? 5. Okay. What to the 5th power is 32? Here's a little hint. When we start talking about the 5th, 6th power, it's probably 2. So you could check it out and see if it is 2 to the 5th. And in fact, it is. So 5th root of 32 is 2. This is a little bit tricky one. 4th root of 10,000. Well, the key in here is all those zeros is probably 10 to some power. And in fact, this is 10 to the 4th. So the fourth root of 10 to the fourth would be 10. Square root of 81, notice I don't put the 2 in there because we don't usually do it for square root, but you can if you'd like. And that would say, what squared is 81? And the answer would be 9. And in fact, we have a property we could use, and we're going to assume the variables are positive if a is greater than or equal to 0, as long as it's not negative, then the nth root of a to the n is just a. So if I look at this fourth root of 10,000 here, you could think of this as the fourth root of 10 to the fourth would just be 10. If I wanted to do the cube root of 27, if I wrote 27 as something cubed, and in this case it happens to be 3, it would just be the base here of 3. So in this case your a is 3. Alright, let's take this a step further and do the same thing we did with simplifying square roots that were not perfect squares. What would we do if we had to do the cube root of something that was not a perfect cube, like 40 for instance? What we have to do is think of, is there a perfect cube that's a factor of 40? Okay, over on the left, over on the right here, I'm going to write my perfect cubes down, at least the first few of them, 2 cubed, 3 cubed, and 4 cubed. Do any of these numbers go into 40? And 8 does. So I could rewrite this as the cube root of 8 times 5. And now I've written it as a perfect cube times the 5. So what's the cube root of 8? I could take that out. Remember, we write that out in front. So I have 2 cube root of 5. So that's the answer simplified. All right, so a cube root is not simplified if there's a perfect cube that's a factor of 40. That's a mouthful, but I don't know any easier way to say that. All right, let's do another one. Cube root of 54. So we want to say, is a perfect cube a factor of 54? And if you're not sure off the bat, the hint is try dividing by 2 and see if the other number is a perfect cube. And if not, try dividing by 3, etc. So if we do 54 divided by 2, we get 27, and aha, that is a perfect cube. So I could rewrite this as the cube root of 27 times 2. And now I take out the perfect cubed. So my answer, the 3 I put down in front, and cube root of 2 is left inside. And so we've got our answer. Now, let's look at variables. What if I take something like m to the 8th and cube it? I get m to the 24th. Using the rules of exponents, laws of exponents, we multiply 8 times 3. You're going to get a multiple of 3, right? Because you ended up multiplying this exponent times 3 since you were cubing the whole thing. And so to go backwards, if I want to do the cube root of m to the 24th, basically it's going to be a perfect cubed if the exponent's a multiple of 3. For square roots, it had to be even. For cube roots, it has to be a multiple of 3. So since this is a multiple of 3, 24, the exponent is a multiple of 3. It's a perfect cube, and we just divide by 3 to get back to m to the 8th. So let's try another one. How about if I wanted to do the cube root of x to the, let's do 18th. So first of all, decide, is that a perfect cube? And why, yes it is, because it has an exponent that 3 goes into. So check it out. It's almost like you just get to divide this 3 into the 18. That's your new exponent. X to the 6th. So what if we wanted to do the cube root of m to the 14th? Notice 3 doesn't go into 14. 14 is not a perfect cube. So we have to break this down so that we have it as a perfect cube times something. So you have to think of the number below 14 that 3 goes into, which will be 12. So I have m to the 12th times, using our laws of exponents, we have 2 extra factors of m. So that's m to the 12th times m squared. And now we could take that out as m to the 4th. So our final answer is m to the 4th times the cube root of m squared. And we'll do some more problems on the next video.